this mind map here to start with, so we're just looking for a missing side or maybe a missing angle later on, and there's two possible situations. The first one is it's a right angle triangle, and if it's a right angle triangle, it will have a little square in the corner. See if I can find an example, like one of these. There's a little square in the corner. If there's not a little square in the corner, you will either need to prove it's a right angle triangle by using Pythagoras, or you need to assume it's not a right angle triangle. Okay, it doesn't matter how much it looks like a right angle triangle. If there's no corner and you can't prove it, it is not a right angle triangle. So if it's right angle, you can use SOHCAHTOA, you can use Pythag. If it doesn't have that square, if you can't prove it, you are looking at the sine rule or the cosine rule to find a missing side or missing angle. Whereas SOHCAHTOA will only work for right angle triangles. So the sine rule. Okay, so you can see the diagram down here, which you've got on your formula sheet. The capital letter A indicates an angle, which is opposite the side, lowercase a. Okay, so the angle opposite side, and where you see here lower cases are sides, upper cases are angles, and these are on opposite sides to each other. Okay, so you cannot have angle B next to side B, they've got to be opposite each other. So what we're going to do with the sine rule is we're going to look for an what I call an opposing pair. So we want one of these pairs. We want to know an angle opposite a known side. Okay, so if you've got a pair, you know the angle, you know the side, excuse me, you can use sine rule. Okay, if you don't have a pair, that's when we're looking at cosine rule. So I'll show you what I mean with this triangle here. Now this one's already labelled. They won't always come labelled for you, but it's not hard to do, and it doesn't really matter what's A and what's A and what's B and what's B, that kind of thing, as long as you've got the relevant information in the right place. So the first thing we're going to look for is an opposing pair. So here I haven't got angle A, so I can't use A and A. I haven't got angle B, I don't know what it is, so I haven't got B and B. I do, however, have angle C and side C. So I'm going to use those as an opposing pair. So the side goes up the top over the angle. Sorry, I'm getting less neat. So once I've got our opposing pair, we can have half of another opposing pair. So with B, we don't have the angle and we don't have the side. So there's nothing we can do there. But here, we have half of this pair. We have the side. We just don't have the angle. Okay, so you don't have to use all three. See how there's three there? You can just use two. And what we're going to do is we're going to cross multiply and solve for A in this case. So cross multiplying, you're going to take the numerator of one fraction and multiply it by the denominator of the other fraction, and the same on the other side. So we're going to be left with 6 times sine of A equals 10 times sine of 30. Okay, and we're going to do a little bit of a rearranging. So we're trying to get A by itself. At the moment it's with sine, it's also with 6. 6 is the furthest away, so we're going to divide both sides by 6. Okay, I tend to not work this out until right at the end. Like you could put this in the calculator and get a decimal again here, but every time you change it into a decimal and every time you round it, you're losing accuracy. So try not to turn it into a decimal until the very, very last step if you can help it. So here we've got to get rid of sine. If your brain can remember back that far, the opposite of sine is actually just the inverse of sine. Okay, and we put everything else the same. So I've just popped that all in my calculator, and I've rounded it off to 2 decimal places, so it's 56.44269.024, and I've just rounded that. Now, something you are going to have to be aware of in this unit is that we will be using different modes on our calculators. This one is in degrees because it says degrees there, we're using degrees. We will also use radians, okay? So if you want to check that your calculator's in degrees, try popping that in and make sure you get the same answer, and that will tell you. So let's do one more with the sine rule. This one they haven't actually given us the diagram, so we're going to draw it ourselves. You can be as accurate or inaccurate as you want with the diagrams. It really doesn't matter. Just don't draw a right angle triangle and you'll be fine. So I'm going to make that A. So whatever I make the angle A, the side A is opposite. Okay, so it really doesn't matter where they are as long as they are opposite each other. Okay, and once I've roughly done that and labelled it, I'm going to put my information in second. So A is 10, B is 12, and angle B is 58 degrees. So this diagram just helps me see kind of what pairs I've got and possibly what other angles I need. It's not necessary, but I find it's a really good visual tool. Okay, so step one, if I get stuck, diagram is the first go-to move. So what I'm looking for sine rule is an opposing pair. Okay, so an angle and a side that are opposite each other. And we can see in the question here we've got B and B, so we have an opposing pair. Or we can look on here, these two are opposite as well. So I'm going to use my opposing pair, 12 over sine of 58. Oh. Okay, and then I'm going to look for another half a pair. Okay, so A, how did I do that? Okay, sorry. A is meant to be over there, not C. So C is not going to do me any good. I don't know the angle. I don't know the side. There's not much I can do there. A, however, I've got half of it. I know that the side is 10. I just don't know the angle. Okay, again, we're going to cross multiply. So the numerator on one fraction multiplies by the denominator on the other fraction. So therefore, 12 times sine of A equals 10 times sine of 58. So I'm being a little inconsistent with my brackets there. You don't need them in there. So now I'm going to rearrange to solve for A. So I'm picking off what's furthest away first. I'm using those algebra skills. I'm doing it again. Okay, opposite of sine. And I'm not putting anything in my calculator. I'm not calculating anything until right at the end. Right about here. Okay, and I'm just going to pause this for a second. Okay, and I got 44.97. Okay, so those are two examples of the sine rule. But we haven't quite finished this one yet. We've found angle A, but the question actually asks us for angle A, angle C, and little c. So we've got quite a bit left to do. And I didn't read that properly, so I haven't left myself much room. So we're going to find angle angle C over here. We're going to find little c over there. So to find big C. So there are a couple of options that you could use here. By far the simplest one is just remembering that in any triangle, all the angles added together equal 180. Okay, so any triangle, all the angles add up to 180. So if we've got two of the angles, we just need to take them away from 180, and that will give us a third angle. Okay, so 180 minus 58 minus 34.97. This unit I've actually used my calculator. We've got 77.03. Okay, and that's my third angle done without too much effort on anyone's behalf. So just remember that all your triangles, all the angles are going to add up to 180. Okay. So the next part is we have to find that side C. Okay, and we're back to the sine rule to find side C. Now we have found sine A, so we could use that one there as an opposing pair, 10 over sine of 77. I would prefer you to use the original opposing pair, because that way if you stuff up the second pair, which it happens, you won't stuff up your third calculation as well. Okay, so if you keep going back to the original one, you kind of get rid of those little problems caused by even just rounding errors or doing little things wrong. They won't happen as much if you use the original pair. So I'm going back to that original pair, and I'm now looking at the C's. So we don't know what side C is. We know that angle C is 77.03. We're going to cross multiply. Doesn't matter which one's on which side. Did not leave myself enough room here. Okay, and I'm looking for C by itself. At the moment, C is multiplying by sine 58. Opposite of multiplying by sine 58 is dividing. So C is 13.79, and there are my 3 answers done. Okay, so sine rule, pretty straightforward. You need opposing pairs to start with, and then half a pair to find the missing piece. And if you've got 2 of the angles, you can find the third one using that 180 minus the 2 other angles. So that's it for sine rule, and you can use it when you have an opposing pair. The other way to find a missing side or an angle in a non-right angle triangle is the cosine rule. Okay, so the cosine rule can be used to find a missing angle if you have all 3 sides, or it can be used to find a missing side if you have 2 sides and an angle. Okay, so this works for any triangle. You can use this for the right angle ones if you really want to. It's a bit more work than SOHCAHTOA, but it'll work for anything. Okay, so that's just showing you. So if C's out the front, you're finding side C, A and B are in there. Okay, if you want to find side B, you swap in A and C. Okay, so you can just swap them around before you put any numbers in. Swap your formula around before you put the numbers in. Okay, so this one here, we're going to try and find the missing side of B. I'm first going to have a look at my known information. So I know an angle and I know 2 sides. Whoop. Okay, so that's how I can identify that I'm using cosine rule. Okay, 2 sides and an angle. I couldn't use sine rule anyway because I don't have any opposing pairs whatsoever. So we're going to try and find the missing side B. So whatever I'm trying to find, I put that out the front. You'll be using the formula sheet. I've just done this with the year 10, so I actually remember it. So whatever's variables you're not using, so in this case A and C, minus 2AC cos of B. Okay, so whatever is out the front, the opposing angle is going to be in the cos part. And then it's just a matter of subbing it in. So we don't know what B is. We do have a know what A is. A is 6. C is 10 minus 2 times 6 times 10 times cos of 76. Now that can go in the calculator and then you can find the square root, or you can do it in one go. Like that. Okay, so if you rearrange the formula first, you're going to make life a lot easier for yourself. You can just use the one on the formula sheet. Okay, but if you want to put B out the front, wherever you see a B, you're going to have to swap for an A, and you have to change this angle to make sure that the angle matches the side that's at the front. Okay, So let's try another one very similar. Oh, well, the same diagram. So we know B. Now they want us to find the missing angles A and C. So we could now do this with sine rule if we wanted to, because we have an opposing pair here and half a pair here. We're going to use the cosine rule just so you can have a look at it. So we're going to use a rearranged one, which I don't actually know off by heart. So we've got cos of A out the front, which is handy because that's what we want out the front. B squared plus C squared minus A squared over 2BC. So that's the same formula as we used there. We make the year 10s rearrange this formula algebraically. They've given it to you already rearranged. So if you want to use the first one and rearrange it, you can, but this saves a lot of time. So we don't know what A is. I normally do this step first. I put the opposite of cos. Okay, just do it all in one step because we've got to get rid of that cos anyway. So B squared, we've got 10.34 squared plus C squared, which is 10 squared, minus A squared, all over 2 times B times C. Okay, and then that goes in your calculator. Okay, and 34.26 degrees. Okay, so that makes it a lot easier. Just if you want to have a look, this is from the grade 10 one, where they start with the original formula and they rearrange. Okay, so that is cosine rule. I'm just going to do one more example for the cosine rule because the example video is going to be a little late for this one. So just to give you a really good idea of what we're doing. So the third side of triangle ABC, going to draw a triangle. We're going to label it. If you can see up here that one side's bigger than the other or whatever, you might want to actually listen to that, or you can just draw a diagram for your own benefit. So we are trying to find the third side. So we've got A and B, we're trying to find C. C's already out the front for us here, which makes it nice and easy. A is 3.4 squared. B is 7.8. Okay, so that can go into your calculator there, or you can do an extra step. I normally do this step as well in step 1. So when I write it, I'll just show you what I mean. When I write it, I'll normally get rid of the square straight away. Okay, so you can kind of rearrange this one here before you even start. It just gets rid of one of those steps, and it makes your communication clearer without having to rewrite everything a couple of times. Just plug it into your calculator and you get 7.95. Okay, so quite easy when you don't have to rearrange it. Probably the most difficult part is deciding what to use when. So if we go right back to the start, if I can find it. So if we're looking for a missing side or an angle, okay, we've got right angle and non-right angle. Right angle, we're looking at SOHCAHTOA mainly. Non-right angle, we're looking for sine rule if we have a pair, an opposing pair. Cosine rule if we don't have an opposing pair, or if we have 3 sides and we're trying to find an angle. Okay, so I hope that gives you a fairly good overview. There are example booklets on the dash and plenty of exercises as well for you to try.